Welcome to the Real Python Podcast. This is episode 125. Have you thought the standard output from Matplotlib is a bit generic looking? Would you like a quick way to add style and consistency to your data visualizations? This week on the show, Christopher Trudeau is here, bringing another batch of PyCoders Weekly articles and projects. We cover an article about the magic of creating Stylesheets for Matplotlib. You can quickly customize plots and graphs with a single line of code. We share additional resources for you to try out new styles and learn what parameters are customizable. Christopher covers an article about using Async for web development in Python. The creation of Python generators inspired the development of async functionality. He discusses recent changes and async additions within Python web frameworks. We cover several other articles and projects from the Python community, including how you can install a pre-release version of Python, caching in Python with LRU cache, ways to get better at debugging, suggestions of libraries that deserve attention, a Python library for creating mathematical animations, and an extremely fast Python linter that is written in Rust. This episode is sponsored by Platform.sh. Discover an alternative to DIY for your web fleet and all the stacks it contains on a single stable platform. Find us at platform.sh. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Christopher, welcome back.
Mr. Bailey, good to be here.
Yeah, I'm excited to dive in this week. We have one little tiny news thing I wanted to hit on, and then one kind of related news item. On the 7th of September, there was a quick security content thing that came out, Python 3.10.7 and 3.9.14 and 3.8.14 and 3.7.14 all became available. Lots of regular bug fixes, and I'll put a link to that for you if you're interested in learning a little more about it. But yeah, keep your Python up to date for security content stuff. The other one is related to the upcoming release of Python 3.11. We've been talking about it a lot this year, and Real Python, our Python release article writer-in-chief, Gerarna Yella, he kind of did a different approach this year. He started writing articles as sort of beta releases and even some of the alphas as he kind of went along, these sort of previews. We're getting to the point now, it will be the first week of October that the new version should be coming out, and we're going to do our typical coverage, which would be an article talking about the new features, a video course, which you're going to be involved with still, Christopher Trudeau there, and we'll probably also do a podcast episode, which has been our trend. So lots to expect from. But I wanted to mention an article that came up on Real Python that Gerarna also wrote that is in a new format for Real Python. It's a QA, sort of question answer format. And this one was, how can you install a pre-release version of Python? And that may seem really obvious, but in some cases it can be a little odd. And there's actually 4 little sections on it. It's a fairly short tutorial/article that gets into it. And the first method that he dives into, maybe I should mention briefly, we've mentioned also that throughout these betas and alphas that you should try it out on your code base. And just to reiterate what Pablo Galindo Salgado was saying, he being the release manager for Python 3.10 and 3.11, his summary is no matter who you are and what you do, test the beta releases if you can. And now we're up to the release candidates, and I would agree that those fall in the same boat as the beta releases that you should try to test them out. And right now, I think we're on release candidate 1. And this article goes through that. And the first one, methodology for installing a pre-release method, is to use a tool called PyEnv, which we've talked about on the show a little bit already. It allows you to manage multiple versions of Python. We have a pretty good article diving into it in a video course if you're interested. One trick with PyEnv generally is that it isn't supported directly on Windows. So there's a fork of it that you can install. And a recent article that I covered from Ian that was about your Python coding environment on Windows, and that sort of setup guide covers the tool Chocolatey that lets you install a version of PyEnv and kind of covers the details there. So I'll include links for both of those if you're interested in learning a little more. The other way of installing a pre-release is to do it directly from python.org. And there's a whole set of paragraphs there talking about it. And then kind of a more advanced way, if you are a Docker user, is to use a slimmed down Docker container with a version of Python in it that you can kind of set up, try your stuff out at it and tear it down. That might be easier depending on, your environment, how you set stuff up. And the last one was using your operating system's package manager. And you can kind of, again, dive into the article to learn a little more about it. So I just wanted to mention it as we're in kind of the season of lots of releases and ways that if you're interested in, doing that testing stuff, this article addresses it pretty directly head on.
And some of these things aren't as obvious as you might expect. The pre-release version is not on the downloads page. And because of how Google works, if you Google it, you might get a link to the alpha or the beta rather than whatever is the most recent.
Yeah, okay.
And I ran into this when I was installing 3.11 in order to start writing the course for October. And it took me about 5 minutes of mucking around until I could actually find the release candidate. And I found plenty of links to the alpha and several links to the documentation, but it took me a little bit to find the actual thing. So this may not be as obvious as you might think it is.
Yeah, in that section about going to python.org, he has a little picture of the downloads. And you see like the normal download stuff. And then kind of in the middle of the page, there's a link that does say pre-releases. But if you were just sort of scanning over it, you could easily miss it.
Yeah, I have missed it several times. I didn't know it was there.
Yeah, he highlighted in a little pink circle to try to show it off.
The other aspect of I find it as well is, and one of the other things that makes it hard to Google is I don't know that the word pre-release is what comes to my mind, right? So
yeah, sure.
You Google Python 3.11. If I had said pre-release, I might have found the pre-release link faster. But
terminology, huh?
It wasn't the word that I would have. My Google foo failed me. Is what it comes down to.
Yeah. If you're interested, and again, I agree with the sentiment there. If you're, a user of Python, it's a good habit to, get into of testing these releases to make sure that everything's going to run smoothly for you when it does come out in October. So what's your first article?
I'm starting out today with Understanding Async Python for the Web. This is by James Bennett. A couple of weeks back, the 4.1 release of Django came out, and the Django core team has been busy over several releases, adding more and more async capabilities to the framework. So there's been a lot of articles kind of popping up around the concept. James's article isn't actually Django specific. He touches on it a little bit. It's more of an intro into async and why that concept is helpful for web applications.
Okay.
And what it means sort of in the industry and how things are changing. So in case you're not deeply familiar with parallelism in Python and all the ways it mangles it, we'll start out with a quick version of async. The Zen of Python has this line, there should be one and preferably only one obvious way to do it. Well, it comes to running multi-threaded parallel code. There are a few more ways than one.
Yeah.
So either the Zen was considered a suggestion in this case, or someone's definition of the word obvious didn't meet consensus. So async and await were keywords that were introduced in Python 3.7. So that's 4 years ago now. And these allow you to write what's called a coroutine, which is a way of writing multi-threaded programming. And the intention here was to make coding in parallel more explicit than in the past. So parallel coding has been in the libraries, but this is bringing it into the language rather than just into the support libraries. And in theory, this can make it easier for the compiler and any tooling to constrain the behavior in ways that are actually good for your coding because you're making it part of the language. So the article starts off by introducing the concept of a generator, and that's code that uses the yield keyword. Most, let's use the word regular programming is linear, right? So if you have a function with 10 lines in it, the computer runs each line in succession and returns. And then the yield keyword's a little different. So when the computer hits the yield keyword, it suspends the function and returns a value. And then it can come back to the function after the yield statement and resume. So the most common use of this is, let's say you've got a function that is supposed to output a lot of sequential data. So if you didn't have generators, you would have to generate the entire chunk of data in a list and you'd return the list. But with a generator, what you can do instead is you can just keep yielding items in the list. So as your function is being iterated over, if you stop, say you break out of your loop, you don't have to generate the rest of the data. So this is a much more efficient way of doing things for large amounts of sequential data. So the async and await keywords build on top of this concept, and they allow you to suspend the execution of a function when you're waiting on some I/O. So there's a huge speed difference between your CPU and your RAM. And then there's another huge speed difference between your RAM and your disk. And it gets even worse between your disk and your network.
Yeah.
So by the time you get between your CPU and your network, your computer's waiting a lot. Your software spends a lot of time just waiting for something to catch up. So what async and await do is they give you the ability to go somewhere else and run some other code while you're waiting for that I/O. So this is called I/O bound parallelism. And implementing it can give you a lot of speed up if your code happens to wait on I/O a lot. If your code is mostly waiting on the CPU instead, doing some fancy calculation, this will not help you at all. And you need a different set of tools, and Python has libraries for that. So I/O bound stuff only. So let's say you were writing for the web. Well, the web is on the network, and guess what? You're doing a lot of I/O wait in this case, right? The ability to add async and await here can make a lot of performance improvements if you're building out web applications. Now, just because this parallelism is available doesn't mean you need to necessarily do anything about it. For example, the web server code might actually use these techniques and you might not have to think about it at all. So just because it's there doesn't necessarily mean you've got to learn this stuff. But
you could just implement something there that
yeah,
is built in.
You build on top of things, right?
Okay.
And in fact, without async IO, what often happens in a lot of web servers is you spawn a whole bunch of threads and Apache takes care of it for you, and you just think about it in a synchronous fashion if you want. Now, there are some cases where that becomes problematic, and one of the more common ones is WebSockets. So vanilla web pages give you just one round trip, right? You hit the browser hits the page, it spits back some HTML, and you view it. There might be some back and forth to get images or whatever, but once it's loaded, it's loaded. So if you wanted to build something like a chat client inside of JavaScript, you don't want to do it this way because otherwise every single time anybody sent anything, you'd have to connect again. And of course, if I don't have that connection open, I can't tell that you're trying to send me something. So WebSockets is a tool that gets around this, and it opens up a network connection and keeps it open and goes back and forth. So the web server now has to be able to do some things in a more asynchronous fashion. And of course, async, the code keyword, can help you do all of this. So essentially, you get to this place where you're waiting and sleeping, and then the chat message wakes you up, and this allows you to do this. At this point in the article, James starts talking about Django and how Django's been slowly adding asynchronous features over the last few years. So Django 3 introduced support for ASGI, which is the asynchronous protocol for integrating Python with web servers. This support means libraries like Channels and Daphne could take advantage of this, and you could start using WebSockets in a Django world. And over the last 4 releases, Django's been adding more and more features, and 4.1 added asynchronous access to the ORM, so wrappers for talking to the database.
Nice.
James basically gives an overview of this and how it's changing in Django, then gives an overview of the libraries that are found with them. So if you're writing something in Flask, then you might be using, say, SQL Alchemy. And of course, if that doesn't support async, you're screwed. So, how it's not just does the web application do it, do all the companion libraries do it as well.
Yeah.
And then he finishes up with a little bit of an opinion piece. He's a little bit skeptical about the rush to async, and I kind of agree with him. It's definitely a useful tool. it's a bit of a sharp tool, and somebody going to be missing some digits at some point because the tool's a little sharp.
Sure.
So I'm a big fan of it being used to help support the libraries, but it's not something that I think web programmers have to rush out and learn immediately. So it's cool that it's out there, and the article gives you a nice sense of what that is and what it means. And but you don't have to feel you're not a web programmer if you don't know any of this stuff.
Yeah, it's interesting how async very often is portrayed as, at least over the last several years, like, oh my God, everybody should be doing this. But it really depends on the project and maybe the scale of the project and so forth. Like, if you're not going to have, I don't know, thousands of connections or what have you, like, I don't know where the big performance boost is going to be. Like, what are the things that are waiting? And so maybe that might get into some kind of profiling or whatever. I mean, I guess it's nice that we're building toward it, but there definitely is a curve of learning it. And I've definitely gone over that. Like, I had a conversation with Brett Cannon and talked about how async was, kind of like this article's talking about, came from generators. And I didn't realize that until I kind of started really studying generators really deeply and sort of the unraveling stuff that he was doing. I'm like, oh my God, this is the same stuff underneath it, and how it kind of led to that development. I guess it's good that it's coming along and moving there, but yeah, I I wonder about the rush. Like,
I think it's because Python is popular and slow.
yeah,
The most common thing Python programmers tend to be defensive about is how do we make it faster?
sure,
And better parallelism is one of the ways you can get some speed up, right? The other aspect of it I find as well is, I've done a fair amount of concurrent programming in my days. My grad studies were based on it. And the one solid lesson to me is try not to do it. It immediately introduces race conditions, and you think regular bugs are hard to find. Anything that is not deterministic becomes really brutal to find.
huh.
So this to me is one of those great tools, but don't prematurely optimize, right? Like if your program's taking 2 seconds and you want it to take 1 second, adding async isn't going to fix your problem, right? If you've got a 6-hour job that needs to run in 20 minutes, then you can start digging into this stuff.
Yeah. So my next one is by Robert Ritz. He has a site called Data Fantic. I wanted to say fanatic, but it's not. It's Data Fantic, but it's a tutorial about a feature that I was not aware of. When I kind of looked around and looked at data visualization libraries just a few minutes ago, I was like, okay, what is the popularity level in Python for this? And so I did, like, just a kind of cursory, not peer-reviewed study of, like, okay, well, what are the popular libraries? And at the top of every of these top lists that I looked at of, like, what should you learn and what are people using and so forth, Matplotlib is always kind of up there. And we even talked offline before we started that there are maybe some other reasons, like coming from academia. It's got a real tight connection with pandas also. So my only problem with Matplotlib, and this is just an aesthetic thing that I've always felt about it, is that it's kind of ugly out of the box. Like, it doesn't have a whole lot of initial style. And this article gives you a really neat way to kind of update that and maybe even apply a consistent style across your stuff. Like, if you're designing a website and you're going to use a lot of graphs and visualizations, it's nice to not have to repeat a lot of code. And it's about the magic of Matplotlib style sheets. I was impressed that this very, very short article took this, very simple looking plot and turned it into something that you would see on, some of these popular websites that show data visualizations. Like, the one that he's trying to mirror in this particular article is a political site called 538. It's a particular blog that's out there, and they have tons of graphs and so forth. So he wanted to kind of create something in that style. And by using this style sheet, he's able to kind of modify this very plain looking Matplotlib line graph and turn it into that. The style sheet, just to kind of get that out of the way, it's saved as a text file. It will have an extension of .mpl style. And you load it in with just a single line, plot.style.use, and then you have in parentheses your file path. It looks kind of interesting. It has comments, basically, that you can use to divide up the sections, and the standard, hashtag # kind of thing to basically, and you can either do them like, topping the comments, or you could do ones that are inline after it just to kind of indicate what you've set up inside there. But as you lay this out, you are things like modifying the grid style, modifying the DPI, the default DPI dots per inch for your graphs that are Matplotlib are 100. And even changing to like something like 150 will make it look a lot better printed or even on screen. He suggests setting it up for 300 for printing. Figure spacing, which is like your aspect ratios, the default is a 4:3 and doesn't always look great depending on what you're trying to format and kind of put it on, especially with things that are very phone based these days. Ticks, the tick labels, their font sizes, and there's a Matplotlib documentation page that I'll link to also that covers this and has all of the parameters that you can kind of adjust, or at least the majority of them at the moment, with the style sheets. And then I also went and did a little kind of deep dive and said, well, what have people created out there already? And I found a couple sites, one that I'll link to that is a GitHub repository with some already existing style sheets, because I think it's handy to kind of see what other people have done with it, to kind of get an idea of like, oh, this could be handy. It's kind of like I think a really common thing as you learn web design is to really look at other sites and then open up what they've kind of created inside there and try to, reverse engineer it. And this set of style sheets actually features some sheets that are inspired by a previous guest, Tanya Allard. She had created this VS Code theme, and he took a lot of the colors and kind of the look of it and applied it there. The tutorial ends with adding a few things that are not available in the style sheet, a couple kind of nice to haves, like in something like a 538 thing, they might have a text, next to the line, as opposed to like having it, directly always in like a legend to the side. So he kind of shows how to do something like that, labeling lines directly, adding additional title and subtitles, and how to create that kind of look. So it's a really nice tutorial. It's very short and to the point. I set it up myself using a Jupyter notebook and just kind of followed along with it, building it as I went. And I was really impressed with like just immediate little changes and stuff with it. But he has a link to a service called Deep Note, which I haven't used. It's like basically a link to a notebook with all the data ready to go. The data he's using in this example is a Kaggle data set that he has a link to it directly at the top. So yeah, I was really impressed with it. I was not familiar with the concept of having style sheets for Matplotlib, and I think a lot of people will find this a very useful feature for them in the future. And again, for something like an organization to be able to set up a look and a feel and keep it consistent, I think is really great.
Well, and simple things can go a long way with this stuff, right? Like you said, just tweaking the resolution a little bit, thickening a couple lines, that kind of thing. And the fact that there's other people who've published these style sheets is fantastic, because if you're not the person like me, I can't do that, right? I look at it and go, I know how I want it to look, and I have no idea what to do with it.
Right.
So mixing and matching other people's stuff out there, right? This was the Picasso quote: "Good artists copy, great artists steal." Well, I'm not a great artist, but thieving seems like the right answer. So totally. It can be really, really helpful with that kind of stuff.
Yeah, even a simple thing like this particular example, he's changing and not having the typical ticks on the left side for a line drawing, because everything is ramping up in this case. It's a GDP growth from 1960 to 2010. And it makes more sense to have the labels on the right-hand side and the ticks and so forth. And so that can be like kind of a head scratcher sometimes, like, how am I supposed to do that? So I was, again, impressed with the results. So check it out.
I think we should spend the next hour talking about visual stuff in an audio-only format. It's the perfect place to do it.
Oh, I'll do more of that at the end here.
Perfect. Excellent.
Okay. Platform.sh provides the cloud-based solution you need, which allows you to manage, update, and optimize your website and/or online application fleet with our secure, unified, enterprise-grade platform. Designed for effective building, running, and scaling of web applications, We are the leader in web fleet management. Are you ready to join the Platform.sh community and optimize your fleet operations? There's no time like the present. Find us at Platform.sh. So what do you got next?
All right. So next one up is a video course called Caching in Python with LRU Cache. The course is based on a real Python tutorial by Santiago of Valderrama. And the course itself was done by real Python's preeminent course creator. My humbleness disallows me from just saying how smart, handsome, and fantastic the creator is. So I'll pause here for you to say something smart and fantastic about the creator.
Can I just clap?
Yeah. Yeah. Well, humble is the key word.
Okay. All right.
Yeah. Anyways, so LRU Cache is a decorator that is found in the Func Tools library and is probably the shortest change you can make to your code that will improve its performance. Your code can benefit a lot from it, and it's like a one-liner you put on the top of the right kind of function. So how do you know if your code's going to benefit from this? The course starts talking about what a cache is and the different ways of managing a cache, and the fact that a cache really is just sort of a trade-off between memory and speed. So if you have something that takes a long time to compute or a long time to fetch, say from over the network, callback, then there's value in keeping it around in memory so that if the data is reused, you don't have to go and get it again. It can just be pulled out of memory. And of course, what you're doing there is you're eating up memory in order to get that performance gain. But that performance gain can be huge. So the example that I ran through in the course is the Fibonacci sequence. So this is an exponential calculation, which means the more data you want, the worse the performance gets. And on my machine, calculating the first 20 digits takes about 0.004 seconds. And then the next 10 digits after that takes 100 times as long, right? So that the slowdown just keeps getting worse and worse. Now, Fibonacci calculation is a recursive algorithm. Each value in the sequence is the sum of the previous two values. And this is a perfect case for caching because all the data is getting reused a lot. So that same code I was just talking about, by slapping the LRU decorator on top of the function, the first 30 digits are calculated in about the same time as the first 10 digits without the calculator. So it's a speed up of like 4,500 times. Like it's huge.
Yeah.
So with the base concept out of the way, the course then goes to show you how to build your own version of LRU Cache, building on top of the code in Func Tools. And the good thing about caches is they keep things around. The bad thing about caches is they keep things around.
Right.
Sometimes you want your data to expire. Say you're caching a web page with some news headlines. The cache can help if you're, caching the logo, but you don't necessarily want to cache the headline because you might be reading yesterday's headline or last week's headline out of your cache. So the course talks about how to adjust the LRU cache to add an expiration concept. And there's a little tangent lesson in here so that if you haven't done decorators before, you can go in there and understand how they, how to read them and what they look like. So there's a tiny little introduction to decorators in case you're new to writing them. So yeah, it's well, I'll let someone else speak to the quality of the content, but the LRU Cache decorator is definitely one of those tools that you want to have in your coding belt. And if you enjoy my sultry tones, well, then you can get another 30 minutes of them and learn the LRU Cache. So there you go, radio announcer voice and everything. So
yeah, I mentioned this as a video course spotlight last week, and I was including it because we were having a conversation about recursion with Al Swigert. We got to the point of talking about memoization, not memorization, but memoization, this idea of sort of holding on to values. And it is a technique that, if you're going to use recursion, might make sense in certain circumstances. And the trade-off with computers now, this idea that kind of RAM is becoming less of this like very, very rare commodity, that's built into your machine and maybe could be used in other purposes, could really, in this particular case, generate really wonderful performance gains and in certain algorithms and certain techniques and so forth. So yeah, I thought it was a great course. I got a lot out of it. And I think that it also shows off the handiness of decorators and how simple it is to just modify your code with like a couple lines, an import statement and a decorator. It's awesome.
Yep.
Cool. So my next one is not per se a Python article, but an article about just general purpose computing, and development. It's titled "Some Ways to Get Better at Debugging." It's by I'm not even sure what to call Julia Evans. She does a lot of different things, a lot of different projects. She creates these cool little zines, little, kind of small magazines about very technical topics that I think is kind of cool. The line that she uses is that they're called wizard zines, and her Twitter handle is at borkb0rk. So they're like things like on how DNS works, or bite size command line stuff, or bite size bash, and learning about CSS and containers and so forth. And I've been impressed with them. There's one that I've wanted to talk about that covers some stuff in Git that I think is really kind of cool, and that she did with another person. So this blog post is very short and to the point, kind of like a lot of her stuff. She's very good at, I think, editing down and just kind of hitting key little points for you to kind of continue your research from. But there were 5 key sort of strategies. And the first was, if you want to get better at debugging, it helps if you know the code base. And this one is kind of 2 sides of the same coin. If you know the code base and you want to learn a little bit more about how it's performing, you can debug it. Or if you want to learn the code base, you can kind of start up a debugger and see what it's doing. And so it's kind of an interesting way to kind of learn that and get deeper into it. She references a paper that she used as kind of a basis for some of these ideas. The paper is Towards a Framework for Teaching Debugging. The paper called that System Knowledge. And then the next one she has is just like learning the systems. Like, to fix bugs, you need to learn a lot about the broader environment, not just really the language. And so in the case of, if you're working on web stuff, which a lot of her topics kind of touch on, you may need to learn about how HTTP caching works, how a database transactions work, something called cores you might need to learn a little more about. And this is called domain knowledge, and learning how to kind of combine all that stuff together. Then it gets into learning tools, which would be, debuggers themselves, or could be additional tools that we've talked about, like profilers, strace, ltrace, TCP dumps, Wireshark, if you're studying network traffic and what's going on. Even knowing how to read your error messages and look at like a stack trace and kind of digging into it. And that is referred to as procedural knowledge. And then she provides a handful of these sort of learning strategies: writing a unit test, writing standalone programs, taking a break, which I can agree, for learning. Sometimes it doesn't always make sense to just keep powering through, because sometimes you're not learning anymore. I like this one about explaining the bug that you're dealing with to a friend, and then figuring out what's wrong halfway through as you're explaining it. I've done that myself. Just talking about something kind of, as you're trying to explain it, it makes you kind of learn the interactions a little better. It's interesting that way.
Are you familiar with rubber duck debugging?
I'm not sure if I'm familiar with that term. No.
This comes from somebody who had discovered in themselves exactly what you're describing, that explaining it out loud gives you the illumination for the problem. So rather than bothering his coworkers, he got a little rubber ducky and put it on his desk. And when he got stuck,
okay,
he would out loud explain it to the rubber duck, and hence rubber duck debugging. And there are websites out there which you can do this to, and they will respond quite appropriately, quack, no matter what you say.
Nice. So there's like an image of a duck that you're speaking to.
Yep.
Nice.
Yep.
Okay. Yeah, I can, I see how that would work, as long as the people around you are wearing headphones.
Yes. Oh, it doesn't say anything about whether or not your coworkers will hate you for it, but you will. It does help you debug. That's the 2 different problems.
Yeah. And then the last one that's kind of in there is talking about kind of GitHub issues and looking to see if other things match with it. Sort of a strategic knowledge is what the paper had called it. And then the next one is just sort of get more experienced at doing this. And yeah, I mean, that's one way to get better at debugging. Do some debugging.
Yeah, practice for sure.
Yeah. And that's how, many things are. And I I know that a lot of people debug via, print statements and so forth, but actually, to go back to, our previous conversation that we've had about this, it's it's a technique that isn't taught that often in the development, like these kind of like low level things of like learning how to program. Very often it's sort of skipped across. But most systems that you have, even idle, which comes with your installation of Python, has a debugger. It's maybe not the most powerful one that's out there, but it can provide you concepts that are hard to initially learn if you're a beginner, like scope and what values are at different times, what's currently being run, and kind of the idea of like jumping through. And it really lets you follow that flow chart of programming, and I think it's a fantastic way to learn more. So if you're at that beginner or intermediate point and haven't been playing with a debugger, it's a really good way to learn your code. If even if the program runs properly now, you can kind of learn more about it. Or if you want to install and run somebody else's code, you can really learn a lot. So, yeah, I agree with that whole get experience part.
But one of my favorites is a TUI debugger called PUDB.
Okay.
And it's a TUI version of PDB, and so it's got a very sort of Borland Turbo Pascal look and feel to it that you can actually see your code, all of your code on the screen at a time,
Yeah.
and set breakpoints and things like that. But one of my most common uses with it, I find, is I set the breakpoint and then immediately dump down into the REPL because it's REPL within the context of wherever you're breakpointed. So you can
Yeah.
play with your variables, you can change things, you can muck with it. And I find it far, I can look at the current value of something, but if I'm only looking at the current value of something, I can do that with a print statement. Whereas this allows me to
Right.
dig in and go, oh, wait a second, wait, oh, that object's not what I expect it to be.
What if people threw weird characters in?
Yeah. And so it allows you to muck around a little bit. And so that idea of being able to get at that REPL spot inside of the context, I find is really, really helpful.
Yeah.
And the other thing, you're talking about learning the code base. One of my favorite tricks for that is, and it obviously depends greatly from code base to code base, but reading the unit tests.
Yeah.
You often learn more from the unit tests than you learn from the code, because the unit tests are expressing what the system is supposed to do. So if you can
Right.
find like a high level, if I'm looking at something that, a web interaction at a high level, it's like, oh, okay, it goes here, it logs in, it does this, it fills in this form, then it does that. And that's expressing what a user is probably doing with the system, right? And that can help you as well, right? So if you take the unit tests and then start adding print statements or debug breakpoints to your unit tests, now you're not even having to figure out what the use case is, because the unit tests are giving you those use cases.
Yeah. Nice. Yeah. So I'm a fan of Julia's work. I think you can get some good ideas of just kind of diving in a little deeper with this short article, but check out some of her zines also. This week, I want to shine a spotlight on another Real Python video course. It dives further into a topic we discussed this week. It's titled Python Debugging with PDB. The course is based on a Real Python article by Nathan Jennings, and in the video course, instructor Austin Sapalia takes you through how to perform the most common debugging tasks using PDB, including setting up breakpoints, stepping through code, viewing stack traces, creating watch lists, and more. I think it's a worthy investment of your time to learn how to use this powerful troubleshooting tool and learn how it can improve your code and speed up your efficiency. And you can also get a printable PDB command reference. Real Python video courses are broken into easily consumable sections, and where needed, include code examples for the techniques shown. All our lessons have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the enhanced search tool on realpython.com. Does that take us into discussions?
I think we're into our discussion land, yes.
Okay. Yeah, we had a choice of two different things, and I kind of went with the second one. This is a tweet from previous guest Will McGugan, who's just been really on fire on Twitter. He's a really good follow. And he posted a question, which was suggest a lesser known library deserving attention. And his little note at the bottom of that is like, even if you're the owner, that's okay. Because, like, that's the problem, is a lot of people are afraid to do self-promotion and feel weird about it.
Yeah, it's horrible if they don't have that humbleness. Like, what can you do?
Yeah, like certain individuals. So I want to mention two that ended up in the list. One is last week's guest, Al Swigert. He, in between our recording and me publishing the last week's episode, he has worked on a library called HumRe. I don't know how to pronounce it exactly, but HUMRE, which is human readable regular expressions, is the concept behind it. And he put it out, was looking for a lot more comments. And I don't know if he felt like he didn't get a lot of attention on it, but I think it's slowly getting a little more attention there. And so I want to definitely re-up that. Problem with regular expressions very often is that you learn them and then 6 months later you're having to relearn them. They're so forgettable. I don't know why, but they just don't really hold in people's heads very well.
I've taught them multiple times and I still look them up anytime I use them. I always get them wrong.
Yeah.
They're fiddly.
So I think this might be a good way to kind of maybe make it be a little easier to read and maybe give you that, one level above abstraction that might help you kind of break into it. So that's a cool one that I saw. And then the other one I wanted to mention that is in there is another previous guest. I'm just throwing out all the previous guests here. But it's from Stargirl. Somebody else had mentioned it, but it's called Nox, Nox. It's a library for testing and kind of automating the testing, kind of like Tox, if you've heard of it. But there's a lot of really kind of nice modifications and kind of a way, different way of looking at that kind of stuff. And if you are familiar with Stargirl's work, Thea Flowers, she does really great documentation. So it also would be a good project to look at just for that. What do you got?
Just a little picture behind the curtain here for our listeners. We don't talk about this ahead of time. Nox made my list as well. So
cool, awesome. Have you used it?
I haven't used it yet. I use Tox regularly. Tox constantly reminds me that one of the features that I depend on it has been deprecated. So I'm counting the days until all the things I do with Tox start to fail. So looking for another library and finding some other things that there's some value in that. So that was definitely on my list to look at. The couple others. One was Auto Editor. This is very specific,
I want to try it.
But it automatically removes dead air from videos. So it looks for your pauses and things and clips automatically. So that's something that I want to play with.
Yeah. I wonder what formats it's picky about and stuff like that.
And there were two more. One seemed like just a quick little utility to keep in mind was a library called Howard, which will convert your dictionaries into data classes and your data classes into dictionaries. So if you want to go back and forth, there's a couple libraries out there which will allow you to do things like dot notation with your dictionaries. So this would be another way of getting at that. And then the last one, which I know nothing about, but it is called PyApp, and it calls itself the Django for CLI apps. So they basically are trying to do some of the pieces that Django takes care of. It's always been a bit of a bugbear for me that Django. There's some things in Django that I would like to be able to pull out of Django easily. I always felt like the library should be like 3 libraries. So I'm always interested when somebody tackles this, because if I want to be able to do some of the things that I do in Django, but I'm not in a web context, other tools can be useful. So I know nothing about any of these, but they were the ones that kind of struck me as interesting and added them to my to-do list. And it's a long conversation on Twitter. Yeah. There's a lot of stuff in there.
It seems to keeps going.
Yeah,
which is good. Dear PyGUI's on there that we mentioned before too.
Yep, and there were a fair amount of data science stuff.
Yep.
So not my bailiwick, so I didn't, nothing popped out at me. But if that happens to be your thing, there might be some cool libraries out there that help you out do something you're working on.
Yeah. I mean, that's the trick. There are so many libraries out there to just even get somebody to just basically mention one kind of helps you kind of float it up to a point to say, oh, maybe that's worth a check if this person is suggesting it. So,
and if nothing else, go give them some love on GitHub and add another star, because it
definitely
us maintainers love that. Feeds the ego. So seems to be a theme today.
Yeah. Well, actually, that takes us into our particular projects that we were mentioning this week. Do you want to go first on this one?
Sure. Okay. So I was looking at a new Python linting tool that's been making the rounds called Ruff. It's written in Rust, which means it's compiled, and that makes it way faster than your typical Python linting tools.
Okay.
And that's the primary focus of Ruff. The maintainer, Charlie Marsh, has written a companion blog where he calls out the horrible performance of a lot of the tools in the Python space, and has basically said, for large code bases, this is problematic. And so not that it's not a useful tool, but I got the sense from the article that it was more of almost a challenge of what can we do better, rather than, hey, this is, you should switch linters. And although it is compiled and written in Rust, he has built a whole bunch of wheels for it. There's like 15 or 16 of them. So you can just pip install it. And it had both versions of the Mac, for example, for both the different processors. So he's covered it very well.
Oh, cool.
So in all likelihood, you do not have to have Rust installed or think about it. You just pip install and you're good. So as I usually do with these kinds of tools, is I just sort of went into a couple of my active projects and ran them against it. The speed was really, really noticeable. I didn't do any formal timing, but by comparison, PyFlakes, which is my usual go-to linter, it takes like a 1 or 2 Mississippis to run on one of my projects. Ruff came back so fast I couldn't measure it. It was basically, oh look, there's the answer. Like it's done. So it was for small to medium-sized projects, it's essentially instantaneous.
Nice.
And nicely, it found a couple of errors that PyFlakes didn't. So that kind of surprised me.
Wow.
I'd missed an import or two in a dunder string method, and my testing doesn't cover my dunder string methods, so it didn't get caught. So thanks to Ruff, I've got some fixes to write, which I think I'm blaming Ruff for rather than taking responsibility. So the only downside I found is the command line arguments were a bit clunky. The help says Ruff, bracket options and then bracket files. And it's got a -- ignore. So if you want to say, hey, don't pay attention to lines that are too long, for example, it kept flagging one of my Django projects, the migration files, the lines are too long. And so you could say -- ignore, whatever it was, E150, and say, don't tell me about that. And I had to fiddle with it, because although the instructions say the parameters go before the list of files, it's actually the other way around. And so this is the kind of thing that can frustrate new users if they're not willing to play with it. But again, this is a first release of this tool.
Yeah, I think it's young. Yeah.
It's young. It's a minor little nitpick, and documentation will fix it, right? So it's pretty cool. A lot of promise. The speed difference has got me hopeful that we can get some more tools in the future like this. So it's definitely worth playing around with it.
Yeah, all the people that I've spoken to over the last couple of years, the most common answer to what do you want to learn next has been Rust.
Yeah.
So it's I'm sure there'll be more tools coming. And it's Ruff spelled with R-U, just like Rust, R-U-F-F.
Yeah, R-U-F-F. Yeah. That's right. Yeah.
So mine is taking off of kind of an update, if you will. Back in episode 21, David Amos was my co-host, and we were talking about projects then, and he had mentioned, this is August 7th, 2020, so that's like almost exactly 2 years ago. He had mentioned, David's really into math, if you haven't followed him on Twitter and so forth. He was following this guy, Grant Sanderson, who's more well-known on YouTube as 3 Blue, 1 Brown, and has this whole animated math learning channel, which is really fantastic for learning, all kinds of mathematical concepts and even statistical concepts and so forth. So I'll put a link to the YouTube for that. But at that point, he was mentioning that, Grant Sanderson created this Python library called Manim, which is basically a mathematical animation library. And I think at the time, he even mentioned that it was a little rough around the edges, if you will, as far as the documentation and support, because it was really just a thing that he had created for his own projects and so forth. Well, in October of 2020, so just a couple months later, a community maintained Python library started to happen. And so now there's a complete separate thing, Manim Python library for creating mathematical animations at manim.community. And if you go to that site, there's really great documentation. It has an example library. It has tutorials and guides, a whole side thing for plugins. If you go to the example gallery, you can very quickly see why this might be of interest if you're trying to animate mathematical things and trying to make videos of these things, because that's what it outputs. It outputs actual little video snippets that you can kind of use from there. It has sponsors, which I was really impressed with. They already have outside sponsors, including pretty big ones like 1Password and a couple other companies. It installs on Mac with Homebrew, so they've got a nice kind of installer ready to go for that. On Windows, it uses Chocolatey, which you've mentioned before. And then Linux, there's a variety of instructions for the different flavors of Linux there. You can try it out just on its own. There's a link right from that main page where it uses a tool called Binder, another sort of Jupyter notebook thing. And you can kind of, again, just try running some of the code and seeing what it does. The animations can have these cool camera settings to like actually move along different planes as things are animating. Again, it's just really pretty what it does. It can do LaTeX, that kind of tool for doing numerical, very advanced sort of formulas and things like that. There's a whole separate 30-minute tutorial just for that. It's a really active community. So yeah, in 2 years, this thing is like, this fork and community version has really exploded. They have a Discord, Reddit, Twitter, all that. So if you're interested in mathematics or you're interested in mathematical animations, you're a teacher and you want to teach some of these concepts, this could be a really handy Python tool to add to your tool belt. So that brings us to the end. Thanks again, Christopher, for bringing all these articles and projects this week.
As always, I'm your humble servant.
And we'll be talking a little more frequently. Got our Python 3.11 release coming up soon. So I'll be talking to you soon.
Looking forward to it.
And don't forget, test out Platform.sh for yourself with our free trial available on our website now. Just search Platform.sh in your favorite browser. I want to thank Christopher Trudeau for coming on the show again this week. And I want to thank you for listening to the Real Python Podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python Podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.